If you are here to find how to configure a router on a stick and how to configure trunk and access interfaces on a Juniper switch, also how to configure VLANs, you found the right place. So in this video, I will configure the topology that you will see next and deliver to you in the full working state. Stay tuned. In this lab, we're going to see on how to configure the switch interfaces and the MX router interfaces. If we'll check our topology here, we'll have to configure the access interfaces for access ports, which are connecting PCs and switches, trunk ports, which are connecting switches and MX routers. We'll also connect routed ports between two MX routers. We will also configure native VLAN and see how the native VLAN is flowing in the network. And let's see what we have in this topology here. We have a network with 3 VLANs. We have VLAN 10 here, VLAN 11 here, and a network with mixed VLAN 20 and native VLAN 100. We are also separating our networks via two layer 3 routers or via two routers which have an interface configured between them. So let's start to configure this topology from this side to this side. I have opened a terminal connection to each of the devices, and this is the QFX2, which is this device here. Also, important thing to mention that if you watched my previous video from other course, which is explaining how to connect each of these devices, I explained that for each virtualized appliance you will have two components, the routing engine and the FPC. And for the MX the same, you'll have the routing engine, which is this one, and the FPC. On each virtualized device, you will log into the routing engine. And the difference between a virtual MX and a virtual QFX is that you connect your ports which will carry traffic on routing engine on virtual QFX, and you will connect your ports which are carrying traffic on FPC for the virtual MX. Also, virtual appliances communicate with routing engine and FPC via this port here, which is port EM1 on FPC and EM1 on routing engine. So if I'm checking here, this is the port which is connected, and this is the port which is connected on routing engine. The same for the FPC. This is the second port is connected to FPC, and also the second port is connected to the routing engine. So let's hide this and let's go to our CLI. First thing, we'll need to check the FPC. We should see this output when issuing show chassis FPC. This means that the connection between routing engine and the FPC is established. Also, when first starting the routing engine, you will see some logs, which are these ones, and this means that soon the connection between the routing engine and the PFE will be established. Go ahead and configure the VLAN 20, and let's check how these PCs in VLAN 20 are communicating with each other. These PCs are pre-configured, and they have PC2 have the IP of 20.20.20.2, and PC3 will have an IP of 20.20.20.3. So we'll go ahead and configure the access ports on the QFX2. So let's go. We'll go with set interfaces XE002.0 family Ethernet switching, interface mode access, and VLAN member of 20. We'll do the same with XE003 interface. So we have our interfaces configured, but we still need to configure VLANs also, because the connection will not work if you don't have these VLANs configured on the device. So set VLANs, we'll name it to 0 and VLAN ID of 20. Let's commit. Let's go to PC2 and try to ping PC3. And the connection is working. So what is happening here? Let's do a capture on these interfaces. Let's go here and clear ARP, and let's test the connectivity again and see what is happening in the background. So if we check the port between PC2 and QFX2, you can see that the first thing that the PC2 did is to send an ARP request asking who has the IP address of 20.20.20.3. PC3 responded, and it said that it has this IP, this MAC address. After what that PC2 populated its ARP table, and now it knows that PC3 have this IP address and this MAC address here. Meanwhile, the QFX also populated its MAC table. So now it knows that in order to reach PC2, the traffic should exit this interface, and in order to reach PC3, the traffic should exit via this interface. This is the interface where PC3 is connected. And if we check the capture from QFX to PC3, we can see that the ARP reached PC3 and the PC3 replied to the ARP request. We can see that ARP was sent to the broadcast address, and this is the destination address. This is the source address of ARP request. And let's see the response. The response will have the destination MAC address of PC2 and the source MAC of PC3. And this is the ARP information which was sent to PC2. After that, the connection was established and the ping started to work. Let's close all of this. And let's say that in our network we have two new PCs, PC5 and PC6, and we don't want to add those PCs in a VLAN because those are temporary PCs and you want to use them for a short period of time and they do not need to exit this broadcast domain. So what you can do is the following. We can see that PC5 is connected to QFX2 and the PC6 is connected to QFX3. So what do we need to do here in case these two PCs are in the native VLAN? So first thing, we'll need to configure the interface from QFX2 to PC5. We'll need to configure the interface between QFX2 and QFX3. And we want to configure the interface between QFX3 and PC6. So let's start with QFX2. So the interface from QFX2 to PC5. We'll use native VLAN of 100 for this interface, and when you are configuring native VLAN, you should also declare that this is the native VLAN, and you also should allow the native VLAN on the interface. So go ahead, family Ethernet switching, interface mode trunk, and VLAN members 100. Also note that the native VLAN will only go on the trunk interface. So if you want to configure native VLAN, you should have the trunk interface configured. Okay, we are done with PC5 QFX2 segment. Let's do the QFX2 QFX3 segment. So set interface is XC004, native VLAN ID of 100, and we also should do the same thing. We need to allow VLAN 100. So family Ethernet switching, interface mode is trunk, and VLAN members is 100. Let's go ahead and commit this. So we're going to log into the QFX3, and as you can see, QFX3 is newly installed. It has the default configuration. What we want to do is to delete all these interfaces, but keep this interface configured because this is the interface which is connecting the routing engine and the FPC. So I'm going to delete the interfaces and add that interface back. And let's set a host name for this device. Also, we'll need to add the root authentication because this is the mandatory statement. Without it, we cannot commit any configuration. And let's go ahead and configure also the interface between QFX2 and QFX3. 00 for native VLAN ID of 100. Family Ethernet switching, interface mode trunk VLAN members of 100. And let's also configure the interface between QFX3 and PC6. Set interfaces XC0.0 family Ethernet switching, interface mode trunk VLAN members of 100, and we also should add the native VLAN here, which is 100. And what I forgot to add is that we should have the native VLAN configured on the switch. So we'll do set VLANs native VLAN ID 100, commit that, and we're going to use the same line on this device here. Let's commit that. And let's check the IP configuration on hosts. Show IP. It doesn't have any IP, so we're going to add one. IP 192.168.1.2/24. We don't have any default gateway because this VLAN will not be routed outside of this broadcast domain. Let's save the configuration and let's try to ping PC5. But first, let me remove these captures here and let's add a capture on this interface. And let's see what is happening. So I'm going to ping 192.168.1.1 and it is not reachable. Let's troubleshoot it for a little bit. And I used XE004 and XE000, but I forgot to add here the native VLAN also. So let's do it again. It says that the interface is not, the IP is not reachable. Maybe I forgot to add something here. Let's check show VLANs. I have the VLAN, native VLAN added. Let's check the interfaces. I have the native VLAN added on interface here on XE001 interface. Let me see if it is the correct one, and yeah, it is. So it looks like that the configuration looks fine, but we still cannot. Actually, let's change the IP here to 192.168.1.1/24 without any default gateway and click save, and let's ping 192.168.1.2. It's still not reachable. We can see that PC5 is sending a request to PC6, but let's start the capture here and send again that request to see if the request is reaching or not. As I can see, the request is reaching PC6 and PC6 even responds to the ARP. Let's check here what is happening. So it would look like that PC5 is not receiving the ARP request. And we have some strange unknown Ethernet frames. So something is not okay here, and something is happening on virtual QFX too. But at the first look, everything looks fine. We also have our VLAN configured. So that is odd. What we can do is we can configure a test interface. So set interfaces IRB unit 100 family inet address 192.168.1.100/24 commit, and let's ping PC5. Show route. It is rejected. Also should use the interface on the VLAN. Native L3 interface IRB.100 commit, and now we can ping PC5. The ping is working to PC5, and let's ping PC2, and the ping is not working to PC6. Because it would look like that PC6 is responding, but QFX3 will send some unknown frame. So let's go back to QFX3 and check interfaces. We have native VLAN added on all corresponding interfaces, and we also have VLAN, and VLAN is configured correctly. So all our configuration is looking good, but still the communication is not possible. So I know that JNS3 and virtual QFX appliances are full of bugs. So I'm going to restart the QFX3. Run request system, reboot both routing engines, because I want also to reboot the FPC. So let it boot, and we'll continue after it will be booted. So it looks like the FPC came online, and let's repeat the test. And now the ping is working. So this is an important thing to know about virtual appliances. They fail sometime. The configuration should be most of the time is okay, but it will not work because of some bugs that these appliances have. Let's go to our capture, and let's check the trunk link between the two devices. As you can see, we will not have any VLAN tag because the trunk interface is doing its job. So it will send untagged traffics. So it will send untagged packets via the tagged trunk interfaces. Okay. Let's go ahead now and configure the interface on the MX. Let's configure a default gateway for these two PCs. So what we can do is set interfaces 000.0 family inet address 20.20.20.1/24. Let's go ahead and hit commit, and let's do a ping test. But first, let's roll back this because this is not the correct device, and let's do the configuration of the MX. So, entering configuration mode, set interfaces G00.0 family inet address 20.20.20.1/24. Let's commit this. Oh, looks like we have some old configuration. I'm going to load factory default configuration. I'll go ahead and add set system root authentication plain text password. Add a password for this one. I will add a host name, and it will be called virtualmx2. And also I will add the interface G000.0 family inet address 20.20.20.1/24. Commit. And let's go ahead and ping PC2 20.20.20.2. The ping would not work because we didn't configure this interface. So let's check interface again, and we don't have XC00 interface. What we're gonna do is set interfaces XC00.0 family inet family Ethernet switching interface mode access. VLAN members will be 20. So what this means, traffic from the MX will arrive at the QFX and will get a VLAN tag of 20. We should do that from MX 20.20.20.2 and the ping works. Also let's ping PC3. The ping also works, so everything is fine. Also note that we will not be able to ping the 1 and 2 168.1.2 because this is an internal VLAN and it doesn't have a default gateway, so these PCs will communicate only with each other. Okay, so now let's move slowly to this side here. On our VirtualMX, let's configure the interface to VirtualMX1. So set interfaces G001.0 family inet address. We'll use 12.12.12.2/24, commit, and moving on to MX1. Let's log in. We will load factory default, set system hostname virtualmx1, set system root authentication plain text password. We'll use Juniper with capital J. And let's configure the interface. G001.0 family inet address 12.12.12.1/24, commit. Now let's handle the last portion of the network. So for that, we are going to go on the QFX1. We'll go ahead and load factory default. We'll delete all the interfaces, but we'll save this interface, which is used for FPC communication. We'll configure system root authentication, which is the mandatory statement, and a host name, virtual QFX1. Now let's go ahead and configure the interfaces. So first one will be interface to PC1. Interface is XC001.0 family Ethernet switching interface mode access, and VLAN members will get VLAN 11, and for the second interface, which is XC002, it will get VLAN 10. Also, we should not forget to configure VLANs. First one will be 1.1 with VLAN ID of 11, and the second one will be VLAN 1.0 with VLAN ID of 10. Also, we should configure the interface between the MX and QFX. So set interface XC00.0 family Ethernet switching interface mode will do trunk in this case. I'll tell you why. And VLAN members 11 and 10. Let's go ahead and commit. And let's check the interfaces. So what we can observe here, we have access interfaces connecting to PCs, and we have trunk interfaces, which is connected to virtual MX. Why do we need a trunk interface here? Because what we will gonna do is to implement inter-VLAN routing using router on a stick topology. And what does this mean? This means that this default gate, this MX here, will be the default gateway for PC1 and PC4. Using the current configuration, if we go to PC4 and try to ping PC1, nothing will happen because the PC1 and PC4 are logically separated using VLANs, and each VLAN have their own subnet. So in order to do that, in order to allow these two VLANs to communicate, we'll have to do some configuration on the MX router itself. So the interface, which is pointing to the QFX, is GE000. We should enable VLAN tagging on it. With VLAN tagging enabled, we'll be able to create sub-interfaces and assign VLANs to those sub-interfaces. So it would look like that. We'll enable VLAN tagging on the physical interface, then we create sub-interfaces and add the VLAN ID. After that, we'll configure the IP address for each sub-interface or for each VLAN. So for VLAN 10, family inet address 10.10.10.1/24. This is the default gateway. So let's add the second interface, G00.0 11 with VLAN ID of 11, and finally adding the IP address 11.11.11.1/24 commit. Let's check the routing table, and we have added the routes. Now let's go back to PC4 and ping PC1, and the ping works perfectly. But let's check what is happening in the shadows or under the hood. I will remove the filter from there. In GNS3, if you add more than 5 filters or 5 interface capturing filters, the topology will break. So keep in mind that you shouldn't add more than 5 filters. With 3 filters, we are safe. So I'm going to ping PC1 from PC4 once again, but before doing that I will clear ARP. And also I will clear Ethernet switching table, and let's issue the ping. So ping works. That's enough. Let's see the traffic capture from PC4 to QFX1. So first thing that the PC4 will do is to find out the MAC address of the default gateway. So it will normally send an ARP request, and it will receive an ARP reply from the gateway. This can also be seen here. This is the interface between the QFX and the virtualmx. So the virtualmx will answer with the MAC address of its interface. Now PC4 will ping PC1, and as you can see, this is this interface. This is an access interface. The traffic is untagged. The traffic will get the VLAN tag as soon as it will enter the QFX. So now the traffic entered the QFX, and QFX will forward the traffic to the MX. And how does the QFX know where to forward traffic? Simple, we'll check the internet, show Ethernet switching table. Okay, maybe let's do another ping. Okay, so moving on. The virtual QFX will send the traffic to virtualmx, and we'll have the VLAN tag of 10. Now the virtualmx will send the traffic to PC1, and it will have the VLAN tag of 11. And if we'll check the PC1, which is this one, we would not see any VLAN tags, because as soon as the packet exited the virtual QFX, it removed the VLAN tag. So let's see again on the picture how the traffic is flowing. PC4 is trying to reach a different network. So what it will do, it will use the default gateway and send the traffic to the default gateway, which is the MX. The traffic will arrive at the QFX, QFX will insert a VLAN tag of 10. It will send the traffic via the trunk interface, and the trunk interface will accept only tagged traffic. So it will check if we have a configured the VLAN 10 to be accepted on that interface, and it would have, so the traffic would be accepted and sent to FPC1. After the traffic arrived at FPC1, I mean virtualmx1, virtualmx1 will check its routing table, and it will look for a route to VLAN 11 network, and it would have that route in its routing table. So it will again use this interface and send the packet to VLAN 11. And because we configured VLAN ID on the interfaces, the MX will add a VLAN tag on the packet. So the packet will arrive at the QFX. QFX will consult its MAC table, and it would see that in order to reach PC1, you should use the XE001 interface, and the packet will be sent to PC1. Okay, let's remove this these captures here. And let's try to ping PC3 from PC1. But before doing that, we don't have this interface is configured here. So, oh no, we have. Let's do a ping to PC3 20.20.20.3. So it looks like that we cannot reach PC3. Default gateway is sending us a response, which means that the destination network is unreachable. Why this is happening? Let's go on VMX1 and check the routing table. And if you remember, the PC3's IP address is 20.20.20.3/24. We don't have this address in this routing table, so we'll have to manually add one. So we'll issue set routing options static route 20.20. It's not 30, it's 20.20.20.0/24, and the next hop should be on virtual mx2, and it should be this interface, which have the IP address of 12.12.12.2. 12.12.12.2. Let's commit this, and let's see if we can ping from DMX this IP. And we can ping from DMX this IP, which is a good sign. Now let's try to ping this IP from the PC1. It will get a timeout. What is happening? When we are pinging the PC3 from this MX, our packet will have a source address of this interface. And the virtual MX2 knows how to reach this interface IP address, and the communication will be established. But what is happening when pinging from PC1? PC1 will have a different source IP address, which is 11.11.11. The packet will arrive at the PC3. We can even check that by starting a capture and by pinging PC3. See, the packets are reaching PC3, and PC3 is responding, but it is getting destination unreachable or network unreachable response from the default gateway. So how to solve this? Because we know that it is sending a response from the default gateway, there must be something missing on the default gateway. So run show route. I don't see the IP address of VLAN 11 here. So I guess I'll have to add it. Set routing options, static route 11.11.11.0/24 with the next hop of 12.12.12.1, which is this interface here. Let's go ahead and commit. And let's run the ping again. Okay, so the ping will work, which means that all good. What will happen if we want to ping PC2 from PC4? Will it work? No, it will not work. Because again, if you look here, run show route, we don't have a route for the VLAN 10. And we should add a static route. But I don't want to add so many static routes. I want just to have one route for everything. I'm going to delete routing options completely along with the old static route, and I'm going to set routing options static route 0.0.0.0/0 next hop 12.12.12. missed hop 12.12.12.1 and commit. Let's run the ping again and it will work. Will it work from PC1 also? Yes, it will work from PC1 also. Will it work from PC1 to ping VLAN 10 network? Yes, it will work. So what we did here, we added a static default route. And if you check the routing table, we'll see this route, which would say if you don't have any entries in the routing table and the destination IP is unknown, just send it via this interface to this next hop address. And we can have multiple VLANs here. Let's say I can add a few more and no configuration would be needed because I have this static route here and I can use it to send the traffic back to its destination. So for our test, I'm gonna ping PC1 and try to reach PC3. For that, I will clear ARP from a mix, clear Ethernet switching table or MAC table from QFX, and I will initiate a ping to 20.20.20.3. The ping is working. Now let's analyze what happened here. So if we look at this capture here, the PC1 generated an ARP request to find out the MAC address of the default gateway. It registered the ARP in its ARP cage it registered the ARP in its ARP table. While the ARP was performed, the QFX also populated its Ethernet switching table, and it knows that default gateway is on interface XE00 and PC1 is on interface XE001. So the traffic entered the QFX. QFX added a VLAN tag. Let's check that VLAN tag. VLAN tag of 11. After that, the packet was transmitted to virtualmx2. This is the packet, and this is a simple IP packet with the source IP of VLAN 11 and destination IP of PC3 in VLAN 20. So the packet reached FPC2, but also virtualmx1 should have virtualmx1 should find the ARP for virtualmx2, and also virtualmx2 should send to find the IP. So virtualmx1 send an ARP request to find out the virtualmx2 MAC address, and virtualmx2 sent an ARP request to find the virtualmx1 MAC address. So these packets have been exchanged. So after doing ARP, MX1 will transfer the packet to MX2. It's also a simple packet without anything fancy. So packet has reached the FPC2. Now FPC2 should send the packet to PC3. So PC2 will send an ARP request to PC3, or it's better to say MX2 will send an ARP request to find out the MAC address of PC3, and PC3 also did that. It sent an ARP request to find out the MAC address of MX2. Okay, so as we said, the packet is now at FPC2, and it did an ARP request to find out the MAC address of PC3, and PC3 and the MX2 is now sending the packet to PC3. If we'll check, here we don't have a VLAN tag because this is an access interface, because we don't need a trunk interface, because our PC2 and PC3 are the only PCs that should communicate with external world, and they are both in VLAN 20. Now PC3 will send a response back to PC1 on the other side of the network. It will have the source address of PC3 and the destination address of PC1. Packet will reach FPC2, MX2. MX2 will redirect the packet to MX1, and MX2 will check its routing table, and it will check this static route here, this default static route, and it will send the packet to the next hop. Now the packet arrived at MX1. MX1 will also check its routing table and will send the packet to the destination. After the communication is established, multiple ping packets will travel from one side to another. So this is how the communication is established between two PCs in different networks. It's a combination of routing and switching. If we have a trunk port, it will accept only the tagged packets. Every access port will insert a VLAN tag on the traffic which is entering the access port. Routers will check their routing table in order to send and receive traffic. Switches will check the MAC table to know where to send the traffic. And PCs have default gateways where they will send traffic with the destination not in their network. MXs will also need to keep an ARP table to know the destination MAC of the interface which they are sending traffic. And this is how routing works. You have learned how to configure router on a stick on a Juniper device, and it wasn't so hard. But there are a lot more things that I can teach you. So sign up for my course, you'll find it in the description. And if you have any questions, just let me know. Thank you and have a good one.